Lesson 2.1, example number 2. And we're considering the function f of x as x approaches x minus 4 over the square root of x minus 2 when x is greater than 0 and x does not equal 4. And also this piecewise defined function also when x is 4 when x equals 4. So it's a piecewise defined function where we have a curve, but there's a hole at 4, and then there's a point 4, 4 that's not on this curve. So we're looking at all epsilon. For all epsilon greater than 0, there exists a delta greater than 0, and a and x, which are elements in domain D, such that we have our absolute value of our function f of x minus f of a is less than epsilon whenever x, the absolute value of x minus a, is less than delta. So this all here is the same as the last example. All right. But what's different here is if epsilon equals to 0.01, notice they didn't give an a. Find a delta such that, again, our absolute value f of x minus f of a less than, now this time we went ahead and put our epsilon that we were given here and here whenever x minus a is less than delta. So the first thing you want to do is simplify our function. And so we're given f of x is equal to x minus 4 over the square root x minus 2. All right, if we took, what we want to do is we want to see if we can cancel as 2, x to the first power is the same as 2 over 2. And 4 is the same as 2 squared. So what we're trying to do here is we're trying to get a difference of 2 squares, factor it out, and see if we can cancel this over square root of x minus 2. Okay, so here we can say, all right, this is x is the same thing as if we said x to the 1/2 parentheses squared. So all I did was I took these two, the 2 over 2, and split it to 1/2 times 2 over 1. So now we've got, and then minus 2 squared. Now we have a difference of 2 squares over the square root of x minus 2. Okay, well, x to the 1/2, that's the square root of x squared. Now we don't want to simplify that. We want to leave it the way it is, minus 2 squared over square root of x minus 2. So now we can go ahead and factor that using the difference of 2 squares. So that'll be the square root of x minus 2 times the square root of x plus 2 over the square root of x minus 2. So now we can see that the square root of x minus 2's can cancel. So now our function has simplified to the square root of x plus 2. Well, since this canceled, right, then that means we have a hole here at the square root of x minus 2, set that equal to 0, since it's in the denominator, add 2, so that's the square root of x equal to 2. Apply opposite of square root is square. So we square both sides, we get x equals 4. So our whole is at 4. So that's going to be our a. We're going to use that as our a. Since our curve has a hole at 4, we want to see what is our limit at that hole. Okay, so that's our a. So we're looking at delta plus 4, and we're looking for 4 minus delta, and so on for our interval. Okay, so we have our a is 4. All right, so from there we can go back and say, all right, we now can say a equals 4. So we have our f of x is equal to the square root of x plus 2, and f of a is equal to the square root of a plus 2. So now we can substitute these two functions into here. So that's going to be square root of x plus 2 minus the square root of a plus 2, and that's in parentheses. And that's less than our epsilon 0.01. Okay, from here we can go ahead and substitute in we know that a, since a is 4, right, since we know that a equals 4, we can substitute 4 in there for a. So this will be the square root of x plus 2 minus the square root of 4 minus 2, because we have to distribute that negative. And so from here, since we're solving for, we want to go ahead and set that equal to 0.01. So this will be the square root of x plus 2, well, plus 2 and a minus 2, they're going to cancel out, right? So the square root of 4 is 2. So that will be square root of x minus 2 equals to 0.01. Okay, so the 2's canceled out, and we're left with the square root of 4, which is 2. So now we go ahead and solve for x. So we apply plus 2.00, and that gives us square root of x equals to 2.01. Well, the inverse operation of square root is square, so we square both sides. And square root, they cancel out their inverse operations. So that'll be 2.01 squared is 4.0401. Okay, so we're going to do the same thing with this equation and negative 0.01. So try to squeeze that in, because that way we can look at it right to left. So this will be square root of x plus 2 minus square root we already know a is 4, so we can substitute that in. 4 minus 2, or plus 2 rather. And that equals to negative 0.01. So we have positive 0.01, now we're going to use a negative 0.01. All right, so we get the square root of x plus 2 minus the square root of 2, and then distribute that to, that's a minus 2 there, equals to a negative 0.01. So again, positive 2 and negative 2 cancel out. We get the square root of x minus 2 equal to negative 0.01. So basically we did the same thing on the right side as we did with the left. And so basically the steps are almost identical except for up to this point, except for the right side is a negative on the right side here, whereas over here it's positive. Okay, so again we apply plus 2 plus 2. But now we're subtracting. So we end up with square root of x equals to 1.99. And again we apply square both sides. And x equals 3.9601. But it's 3.9601. Just a little bit. Give us some more room here. 3.9601. So we're going to pick the smaller of the two numbers. We're going to pick this one. And so when we do that, we're going to use this equation here. So first we used the epsilon, the absolute value of f of x minus f of a is less than epsilon. Now we had to solve for x, for positive epsilon and negative epsilon. Now once we find out which one we're going to use, now we can substitute in. We said before that a is 4. So we're saying that absolute value of x minus 4 is less than delta. So now we're gonna find delta. Well, we're gonna use this 3.9601. 3.9601 minus 4 is less than delta. And so we're going to get so the difference between these two, so basically this would be, because we're finding absolute value, we're going to set it equal. And so we get 0, because it's absolute value, we're going to get a 0.0399 is our delta. And that's our answer. Okay, so to summarize it, first thing we did was simplify this function here. Use the difference of two squares and then canceled, and we got f of x equals square root of x plus 2. If you don't understand it, go back and look at the video again. And so from there we were able to plug into this equation. said is 0.01, that goes in there. The function f of x, this goes in here. We determined that was 4. Since we're going to find that we got a hole at 4. And that's what we had here. So we plugged 4 in for A and then worked it out and got 4.04. And then we went back to the same thing with negative 0.01. And we got 3.9601. That's a smaller number than 4.04. So the reason why we want to go with a smaller number is we're more guaranteed of finding the epsilon at 0.01 with this number. And so we went with that, and we found delta 0.339. 0.399.